So we're going to first look at tutorial number 1, then we'll do number 1 and also number 2, which is this part. So let's start with this one. Here we will say define and differentiate between probability and statistics. So probability, here we can say that it's a branch of mathematics that quantifies the likelihood of an event happening, or that checks the probability of an event happening, or let's just write it in this way, that quantifies the likelihood that an event will occur. Then statistics. This is a branch in mathematics that deals with the collection, analysis, and interpretation and organization of data to understand, so that we can understand the patterns of past behaviors from the observation. Organization data, understand past observations. So that's how you will define it. Then here they say, what is the difference between probability and statistics? So with statistics, here we know that statistics, it uses observed data but probability it uses a known predicted sample or population. So that's how you will differentiate between these two, because they're asking us to also differentiate. Predicted sample. So this is the keyword, predicted sample, when you explain probability. Then when it comes to this one, they say define what is a random experiment, what is a random variable. So I'll just explain them here. Random experiment. This is a process that leads to 1 or several simple possible outcomes. Where the exact result cannot be predicted. So this is how you would explain it. And then a random variable. This is when we're talking about x. So this is just a unique real number that will lead to a certain outcome. It's just a unique number that will lead to a certain outcome. So this is what we call a random variable. So each number that will to a certain outcome. Then let's see the next question. They're saying give two examples of a random experiment. For each example, define what is an associated random variable, then determine all possible values of the random variable. Then they say define two events and compute their probability values. So I'm going to first start with the first, define an associated random variable. They say define an associated random variable. So here they just want us to give an example of a random variable. So we can say let x be the total number of hits obtained in 3 tosses. The number b, they're saying determine all possible values. So want to write all the possible values when x is giving us the total number of bits obtained in 3 tosses if we toss a coin 3 times. So letter B, we know that if we're tossing 3 times a coin 3 times, it means we'll have 2 to exponent 3, we'll have 8 possible outcomes. So we can have tail, 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 head, tail, 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 head, tail, 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 head, tail, head, tail, head, tail, head, 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 head. So here we could have given another example. So I just used this. Someone could have said, suppose let x be the total number of bits obtained in 2 tosses. So if it was 2 tosses, you'll have 2 to exponent 2. So you have 2 possible outcomes. But in this case, I'm using this. So I'm going to remove that. Then we'll go to letter B. So we'll know that x will, before I go to letter C, x will take You can either have a 0 head or 1 head or 2 heads or 3 heads. So these are the possible outcomes. Okay, then we can write it in a tabular form. We say the number of heads obtaining a 0 head. I believe if I'm writing it in a table, here you'll have to write what? 0, 1, 2, 3. Then here you write outcomes. Obviously, here you won't have nothing. So maybe we can give an example of that, but this is simple, something that you know, draw a table. So I'm going to skip this part, and then they're saying they define two events and compute their probability values. Two events. So you just create your own events. Let's say you say event A, obtaining 2 heads, and then maybe you say, so you know that's why x is equal to 2. So you are going to write the possibilities, and then you say event B, you say obtaining at least 2 heads. So at least we know it's when x is greater than 2, right? Meaning you are having more than 2 heads. So this will be the outcomes. You already have the samples, exactly 2 heads. It means you'll have 1, 1, 2, 3. So you'll have these outcomes: head, head, tail, head, tail, head, and then tail, head. Let me just fix this one: head, head, tail. Then this one, so we're going to have more than let's 2. So I'll take 1, 2, 8, so 8, tail, and then head, tail, head, tail, head, head, head. Then the probability of event B happening, it means the probability of x being greater or equal to 0, and then this one 3 over A, the probability of event B, meaning where x is equal to 2. So now go to the next one, because number 5, consider two random variables x and y with the probability, mass, and density functions j are probability. So A must have none for a probability mass function of f of y and g of x. We must have that, must have the machine is non-negative. For all values of x. Number 2 is the first condition. The second one, the summation of g of x from x equal to 0 to infinity must be equal to 1. And also similarly for of x non-negative condition. So f of y must be greater or equal to 0 for all values of x. You will say for all values of y. The PM g of x is a PMF, and this one is a PDF. So g of f of y is a continuous function. So we're going to say we know that g is a PMF. So we cannot say similarly. So we're going to say since this one is a PDF, so this one is fine, but you'll have to change this one to integral or continuous. And let me see the next question. They're saying, suppose two dice are rolled together once. Suppose x denotes the sum. The pair of numbers facing up are recorded. Derive the probability mass function of x and place this using a. So I'm gonna come here. So now that we've got the sample space will be 36. So let's be rolling two dice. So we now have these possible terms. And have 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 3, 4, 6, 4, 1, 4, 2, 4, 3, 4, 4, until we've got that 86 possibilities. Six. So this is giving us 36 possibilities. So all we have to do is to construct a table. So I'm going to say, let's check out, they asked the question here. They said, derive the PMF and present it using the table. So you just have to put this in a table form. So I'm going to do the sum of x values when we get 2, 3, 4, 5, 6, 7, 8, 9. I should be writing this that side. Writing here the sum of values of x. 2, 3, 4. I think we should just write it in a table format, make things easier. The sum. So when we get 2, when we get 3, 4, 6, 7, 8, 9, 10. So unfortunately, I'm not gonna be able to squeeze all of them up. But I think maybe we can let's just write them the way I want them to write them. So I'll write them one by one. We have 2. Then the outcomes, just write them here. Then the probabilities. So I know I can have 1 and 1. That will sum to 2. That's the only veil that will sum to 2. Then I can have 3. This will be 1 over 36. Then for getting a 3, you will have 1 and a 2 and a 2 and a 1. So you'll have 1, 2, 2, 1. So this will be 2 over 36. So you do this up to until you get to 12. From 1 up to from 2 up to 12. And on the last one, the only value that will give us 12 when we add is 6 and 6. So this will be 1 over 6. When we look at the probabilities. Then here for getting a 4, you'll have this 1 and a 3, 2 and 3 and a 1. So you'll have 3 possibilities. 1, 3, 2, 2, 2, 1. So you'll have 3 over 36. So at the end of the day, when you add this, you should get 36 out of 36, which is just 1. Now let me go to the next question. They were saying derive the probability. Suppose that the two dice are rolled together. One, suppose X denotes the pair of numbers facing up are recorded. Derive the probability as function of X. Present it using a table. That's what we did. Then compute a probability of X being greater than 4 over 5. And compute the probability of X less than 9,75. Obviously, you're going to use the table, and I didn't finish everything up. Let me see. So we've done number BI. Then now they wanted us to do this Roman first BI. So they wanted us to check the probability X greater or equal to 4,5. So you go to use the table and check which values are greater than 4,5. And which of the values are less than 9,75. X less or equal to 9,75. Yeah, so obviously this is the same as you're going to check the probability when X is greater or equal to 5. The values that when you add, they're greater than 5. So you'll check this one, and also this one will be equal to the probability of X when it's less or equal to 9. So this will be equal to 1 minus the probability of being 10, probability of being 11, plus probability of getting a 12. So after summing this, you should get this plus 2 over 36 plus 1 over 36. So if you complete the table, you should see this. And then similarly for this one, we should get 1 minus the probability of being 2 plus probability of being 3 plus probability of being 4. This will be 1 minus 1 over 36 plus 2 over 36 plus 3 over 6. So you'll do something like this and then you get your probabilities even here. Then the next one, they are saying calculate the mean. I'm just looking for the mean. Y is equal to 2x plus 5. So obviously, if you know the expected value, which you'll have to first calculate, then you'll say y is equal to 2 times the expected value of x plus 5. So I suppose to get e of x, you're going to say the random variable times the probabilities, right? So you're going to check from 2 when x is equal to 2, 3 when x is equal to 3, obviously. Then you'll sum this until you get to 12 times 1 over 56. So the answer here, it will be 7. Then you'll have y is equal to 2 times 7 plus 5. And then this will give us 90. And here they say, let y be a random variable with a normal distribution. Write the PDF. Write the PDF of y and show its requirement of a density function. Okay. So I'm looking for the PDF of y, and we know that for uniform distribution, the formula is 1 over b minus a. So this will just be 1 over 8 minus negative 2. This will be 1 over 10. Then our PDF will simply be 1 over 10. Y is between 8 and negative 2. 0 otherwise. Then they say find the mean and the variance of W. Find the mean and the variance of W. So obviously we're having W equal to 2y minus 3. So the expected of y, it will be a plus b divided by 2. You just find the average. Then you do negative 2 plus 8 over 2, you'll get 3. Then the variance of y. So in order to get the variance, you'll use this formula. So I think I must just write these things here. So this one was the expected. Now we're looking for the variance of y. So we know that it will be y squared minus the expected of y. So you'll have to perform this. So this will be a plus b all over 2. I believe all to exponent 4 minus a plus b all over 2. Let's just see what we'll get. A plus b all squared over 4 minus a plus b all over 2 all over 4. Then this will be a plus b all squared minus 2 into a plus b. So after simplifying, you should get something like this. So you'll also check this thing out, how we derived this formula, right? Because this is how the variance will look like. And then here you just substitute. We know our b is equal to 8 and our a is equal to negative 2. So we will have 8 minus negative 2 all squared over 12. And this will be 25 over 3. This 8,33. So that's the variance of y. Let's check the next question. They say, let us see letter D. We have managed to find the mean and the variance. Name what each of the following represent. E of x. Obviously, this one represents the MGF. And then this one obviously is the variance. And then the first one is going to represent the mean. So let me just write these things. So the first one, it shall be the expected of x. This is just the expected value or mean of a random variable. So you must also include this of a random variable x. 2, expected of x minus expected of ex all squared. Represent the variance of a random variable x. So you can also write it like this. Then the last one was the expected of tx. This is the moment generating function of a random variable x, usually represented by mxt. Okay, then let's check the next question. They say, find the values of the expected using the exponential distribution beta equal to what? Equal to 2,5. So for exponential, we must find the variance, the expected, and the MGF. So already given beta is equal to 2,5. So exponential. So beta we're given is 2,5. So since this is a exponential, the beta here, it represents the mean. So I already given the mean, 2,5. So in order to get the variance, it will be expected of x minus ex all squared. It will be beta squared. So it's just 2,5 all squared. So you must know these properties. 6,25. Then the MJF, ATX, is 1 over 1 minus beta t. And this will be 1 over 1 minus 2,5 t. So you'll get this. And then I think you can still continue to manipulate that, but I'm going to leave it there. Then you'll say 4 t less than 1 over 2,5. Because if t is equal to this, you'll get undefined. So that's our MGF. So we also have another way of doing this. So this is when beta is the scale parameter. So I'll also check on the textbook, and then this is when beta, this is the second method, when beta is a rate parameter, not the scale parameter. So meaning the mean here is 1 over beta. So you'll have your expected as 1 over beta, 1 over 2,5, 0,4. Then your variance it will be 1 over beta squared. Then you'll have 1 over 2,5 all squared. And you'll get 0,16. Then the MGF, it will be beta over beta minus T. So I believe we'll have to also check on the guide which one are they using, but I believe it's the first method. But even if you write this, you'll still be correct. And then even here, you'll say for T less than 2,5. It cannot be equal to 2,5. Let's check the Poisson distribution. They are saying find the value of the expected when beta is equal to 2. Then we'll also do the binomial. So letter B, beta is equal to 2 for a Poisson distribution. So on Poisson, beta is equal to the mean is equal to the variance. So meaning your variance will just be equal to 2. Then the MGF, it will be Euler beta ET minus 1. This will be E2 ET minus 1. Then let's go to the binomial distribution. So they have given us that P is 0,25 and is equal to 10. So we're having this. Now you'll see the mean is equal to NP. This is the general formula on a binomial distribution. Then you'll have 10 times 0,25. This is 2,5. And you get your variance. Your variance is equal to NPQ. You can write it like this, but at the end of the day, this is the same as NPQ. So you'll say 10 times 0,25 minus 0,25. Then you'll get your value 1,87. Five on it end. So we have derived this on the first part of the semester. So we know that this is actually equal to Q plus P, or we can take out P here. You will be left with -1. Oh, you'll be left minus et all to exponent x. So this will be equivalent to 0.75 if I'm substituting on the let's just, because this one I was just showing you how to derive, so I'll just plus 5, that's our p, plus 0.25 Euler to exponent t to exponent 10. So basically this will be our MGF. So that will be the answer expected of each. Then, so on letter F, they are saying for each of the probability distribution, find the value of the probability of x less than the mean of the distribution. So if we focus on this question, so must check for every distribution. So must check for exponential, Poisson, binomial when the probability of x is less than or equal to the mean. Here the mean, I believe it was 5.25. So let me go down there. So must check the probability when x is less or equal to 2.5. This one is for the exponential. And for Poisson, we had our mean as 2. And then for binomial distribution, our mean was also equal to 2 here. So all we have to figure out is the formulas. So the formula for this one will be 1 minus e to exponent. We've already derived something like this. So they're saying for each, find the value of P less than the mean. Okay, let's go back there. So for Poisson, this is what we're going to do. Let's start with the one for Poisson. It's the simplest one. It will be, this will be equal to e to exponent negative the mean. Remember, you're going to put the mean, then let me use lambda x over x factorial. So you're going to have Euler negative 2 to exponent 0 factorial 2 factorial. And then this at the end, it will give us 5 Euler to exponent negative 2. So that will be the probability of x less or equal to 2 for the exponential. Then for the binomial, you will use the formula n chooses x, px 1 minus p n minus x. So we'll check for x equal to 0, x equal to 1, x equal to 2. So obviously you'll have something like this. Our p was equal to 2 comma 5, 0 comma 25. Recall that. And then it means you'll have 10 choices, and our n was 10. You'll have 10 choices 0, 0 comma 25, 0, 0 comma 75. Then this will be 10 minus 0. Then you also add the other ones. Yeah, so you'll just add and then you get the final answer. Remember, we're looking for less than 2, so you just check from x between 0 and 2. Then for the one for exponential, remember, I want to check for the probability of x less than this. So you're going to say I have my function. You must first get the equation of the function. So this one is a bit tricky. So the formula is going to be like this. For the function on a exponential, you will have f of x is equal to 1 over beta Euler negative x over beta. So this is the formula for your function. So now if you must find the probability of x less than that, you'll have the integral from 0 to 2 comma 5. Then you just write your function here, dx. So you'll have 0 to 2 comma 5 negative x over 2 comma 5 dx. Then you'll integrate this. At the end of the day, you must find for me this answer. Must be able to get that. So that will be the probability when x is less than that. Or perhaps let me try doing it here. For the exponential, we're saying that you'll say the integral from negative infinity to infinity of 1 over beta negative x over beta dx. So you'll have a 0 to 2 comma 5 since our x was 2 comma 5. And then you'll have 1 over 2 comma 5 Euler negative x over 2 comma 5 dx. So can take out 1 over 2 comma 5. So we'll have to find the integral of this. So you'll get negative Euler negative x over 2 comma 5. Times what? So this will, let me see the derivative of this. Then this will be all over 1 over 2 comma 5. And if you divide with that, you'll get a 1. You'll get 1. So this will be from 0 to 2 comma 5. So at the end of the day, you'll have negative 2 comma 5 over 2 comma 5 minus negative negative 0 over 2 comma 5. Then you'll have 1 minus Euler to exponent negative 1. So that's how you'll get that answer. So this obviously requires you to practice. Then let's see. So let me look at this one. They are saying write down the distribution of x and find the mean and the quantity of that. You are having the mean and the variance. So this is a normal distribution. So we have your mean 12.25. Our variance is 4. So write down when they say write down the distribution function of x, you'll just say x is normally distributed between the mean and the variance. Then letter B, they say find the mean and the variance of this. So I want to find the mean and the variance. So we'll start with the mean. Of y. So this will be the mean of y. So this will be equal to 2 over 5, the expected of p1, x1 plus 3 over 5, expected of x2 minus the expected of x3 is 4. So since we know that our mean is equal to 12.25, so it means you'd come here and put 12.25. And our final answer, you should get a 24.5. Then to get the variance of y, we know that if you have the variance of ax plus by, this is the same as a squared variance of x plus b squared variance of y. So I'm gonna use this property on this guy. So it means you'll have what? Y variance of y is 2 over 5 squared variance of x1 plus 3 over 5 whole squared variance of x squared plus negative 1 squared variance of x3 plus 2 squared variance of x4. And at the end, you should get, after simplifying these things, we already know that our variance is equal to 4. So you'll put 4 here. So you'll have what? 4 over 10 over 25 times 4 is 4 you'll have 4 here. Then your variance, you should get 22,08. Now let's see the next question. They say find the standard score of x and y. Okay, so the standard score of x and y, it will be x minus qx. We'll have something like y minus uy. So here you'll say I'm having x minus, our mean was 12,25 all over the root of 4. So you'll have x minus 12,25 over 2. And here you'll have y minus the mean of y. The mean of y, we found 24,5. You see the answers are different. This one is, remember, this one is the mean of x and the variance of x. But here we found the mean of y. This was the mean of y. And the variance of y, we found 22,08. So it means even here you will substitute 24,5, the root of 22,08. So you should get your z score of y to be y minus 24,5. Then letter D, they say develop the sampling distribution using the MGF. They use the MGF to show that the mean will be equal to this, and the sample mean will be 1. So using the MGF method, so they say develop the sampling distribution using the MGF method. So it's x is normally distributed between the mean and the variance. The MGF is equal to u mu t plus half variance squared t squared. X bar is 1 over n summation of xi. So we're having, let me see, we're having how many? We're having 4. They say let x1 up to x4. You see, so we're having 4. So in order for us to calculate the expected mean, the mean, the average mean, you will say x1 plus x2, x3 plus x4 all over 4. Then this will be the MGF. Now, it's the expected of Euler T x bar. So this will be the expected. Then you just put the formula C. Then you say the expected of Euler T over n x2 plus x3 plus x4. Now, here you're going to change this to be the product of mxi's. So you'll have mx1 t over n by the MGF definition times mx2 t over n. So xi is independent. Since the xi are independent, the expected values is equal to the product of their individual expected values. So this is actually the same as having something like this up to expected of x4. What I wrote here is actually equivalent to this mx3 t over n mx4 t over n. So this is the same as the product from I1 mxi t over n. So this sign is for product. Then this will be equal to the product from I equal to 1 of Euler. So now we're replacing that. We're having Euler to exponent mu. So we're replacing this on the MGF formula. We're replacing on this formula here. So we're going to replace where there is mu with T over N. Mu T. Where there is T, we're going to replace with T over N, where there is T. So and then this will be plus 1 over 2 sigma squared T over N all squared. Then you simplify this. This will be the same as Euler. And this, now it will change to, we're going to remove this by putting all to exponent N. That's how you remove it. So this will be all to exponent N. Then you distribute this. Yeah, so you'll have this as your final, as our final answer. This is our MGF. Remember, we're calculating the MGF using the MGF method. So that's how you should do it. And the second, I think the last question, they said find the standard error. Use the MGF to show that the expected value is equal to 12,5 and the standard error of the mean is 1. So the standard error is basically find the standard error. This is letter E. Find the standard error. So to find the standard error, this is the square root of the variance. So it means you must first know your variance, right? So we're going to first find the expected of x bar squared. Remember our expected value, we already had it. I believe it was this. Let's just go back 12,25. You see, we had it there, 12,25. So what you're going to do, you must now find the expected value of x squared. So you're going to find the derivative. The second derivative of the MGF is equal to this. They are equal. So this is by property. Okay. So we're going to say the second derivative. Firstly, we must know what is the first derivative, obviously. And we must actually, so we know that our MGF was equal to this. From the previous question, we already found it. It's this one. So I'm just gonna copy it here. Plus half sigma squared over n t squared. So the first derivative, it will give us 12 comma. Let's first substitute. We're going to first substitute our mean is 12,5 t plus half the so since we're from x4, then this is t squared, and finally you are going to have this e 12,25t plus half t squared. Now, although we already know what is the expected value, we can calculate it because it's going to be equal to the MGF when t is equal to 0. So we're going to have the first derivative of this will give us 12,25. I'm sure you know how to differentiate the exponential plus 2, your plus t from that. And then you'll have Euler. You just write the original equation as it is. Then now you can now substitute t. And this will give us 12,25. So, but we already knew what is this, expected of x. So what we need now is the second derivative. So now we must differentiate that again. So this was going to give us Euler to exponent 12,25 t plus, remember this will give us 1. We are going to use a product rule, obviously. So if I start with this one, the derivative will give us 1 now. So it means you'll have t plus 1 over 2t squared plus, since we're using product rule, then you keep this one plus t and then this will be all squared because this will give us the same answer as that when you differentiate, and then you write the original equation as it is plus 0,5 t squared. So now what you do, you just substitute your 0. Remember this is separated. So obviously this was going to give us 0. Then I'll have a 0,5 0 squared. So basically you'll have our final answer will be 151,06. So this is your expected value EX squared, or our second MGF. So now you will say variance you write this and then you substitute. So obviously we know what is our variance is 12,25. So you'll finally get your answer to be 1. So now the standard error of x bar will be the root of variance as I've explained. So this will be the root of 1, which is, so I'm gonna end it.